Alright, okay, so in this second video, we are going to talk about what's the basicity of acid. Basicity is the maximum number of H plus ions which can be deionized, or I mean, which can be dissociated or ionized in a molecule of acid. Okay, so we have, okay, let's look at the strong acid examples. Okay, so HCl is what we call a mono. Mono means one. So one molecule of acid produces one H plus, one acid, one H plus. We also have a case of a dibasic H2SO4. So one molecule produces two H plus. So H2SO4 gives you two H plus. Okay, so that's a meaning of dibasic. One molecule of acid dissociate to produce two H plus. Okay, we also have tribasic, but tribasic usually, please change this to 3. Okay, okay, so tribasic, I think I only have the weak acid kind of example. Okay, this is, if you want to know, this is actually phosphoric acid. Okay, the anion is actually PO4 3 minus. It's a phosphate ion. This one is a sulfate, SO4 2 minus. So I hope you haven't forgotten about your 6 best friends. That means the polyatomic ions. Okay, things like sulfate, SO4 2 minus. Okay, the name as well as the formula. Okay. Alright, what's a hydroxide? It's OH minus. What's a carbonate? It's your CO3 2 minus. What else do I have? Nitrate, yeah, very commonly seen as well. NO3 minus. 3 at the bottom, minus at the top. Then we have phosphate. PO4 3 minus. Okay, and then also one last one. A polyatomic cation. That means a positive ion. 4 at the bottom, plus at the top. Alright. Okay. So yeah, that's the meaning of basicity lah. Okay, so tribasic means one acid produce 3H plus okay, ions. Okay, so just like acid, you have strong and weak. Alkaline, there's also strong and weak. Okay, definition almost the same. Okay, strong alkaline means completely dissociate or fully dissociate okay, to produce your high concentration of OH minus ions. Okay, weak alkaline means partially dissociates to produce OH minus ions. Okay, usually the pH is around 13 to 14 for strong. For weak, usually it's like 8 to 10. Okay, but strength is one factor lah. The concentration of the alkaline and the acid itself also plays another factor lah. Okay, so example is your NaOH fully dissociate, or potassium hydroxide fully dissociate, very famous one. And then you have ammonia. Ammonia one is quite special. If you realize, ammonia is like that. 8 plus H2O, they give double headed arrow, give you NH4 plus and OH minus. The formula itself doesn't have hydroxide. Okay, you need to add into water, then you get the hydroxide. Okay, this is quite unique itself. Okay, so do take note lah. Alright. Okay, so let's look at some questions just to have a quick test of what you understand so far. Okay, so determine if the following statements are true or false. Okay, so okay, so the first two actually test you the difference between bases and alkalines. Okay, so remember that down here we discuss that bases is all metal oxides or hydroxides. There's soluble, insoluble ones. Okay, soluble ones are called alkaline. So bases got two kinds. Soluble kinds and insoluble. Soluble ones, we call them alkaline. So basically all alkalines are bases, but not all bases are alkaline. So that will take care of the first two questions. Anyway, bases are all metal oxides or hydroxides. Okay, I hope you can at least know what's a base. Because quite sad one. Always after a while, you all don't know what is a base when people ask you. Yeah. All right. Okay. So let's go on to the next questions. So a solution of hydrogen chloride in methyl benzene can conduct electricity that is forced because the solvent is not water. Okay. So you will not dissociate lah. Okay. So this is false. Only aqueous solutions have a pH value, solids and liquid. Okay, this is true. Okay, because you need water in order for the dissociation of H plus and OH minus to happen from acids and alkaline respectively. Okay. Uh, Okay, next one is strong acid means that more than half of the acid molecule actually dissociate. No, actually this is false. It's all 100% all all of the acid molecule will dissociate when it's strong. You put in 1 million molecule, all 1 million will dissociate. Okay. Strength is the degree of dissociation. Yes, this is true. Weak acid contains its own molecules. Yes. All right. Okay. So that's why the concentration of H plus the hydrogen ion is low usually. Okay, compared to concentration of acid. Yeah. All right. Okay, then let's look at question number 2. So give the name and formula ion which must be present in any acidic solution. Okay, so remember, okay, definition of acid is a substance that dissociates in water or ionize. They mean the same thing. Okay, in solution to produce your H plus ions. Okay, so that's the very definition of acid. Must have hydrogen ions, H plus ions. Okay, the formula is this, the name is this. All right. Okay. Likewise for alkaline. Okay, what's an alkaline? Alkaline, actually the definition is just change the H plus to OH minus. Substance that dissociates or ionize in solution, okay, to produce hydroxide ions, OH minus ions, okay, which is hydroxide. Okay, this is the name, this is the formula. All right. Okay, then next thing, dry hydrogen chloride, dissolves in water to form an acidic solution. Explain why. Okay, so back then, I mean a few pages earlier on, okay, we look at HCl gas. Okay, this is a molecule. There's no ions. But when you throw it in a beaker of water, the dissociation happens. Okay, you become HCl aqueous, then the dissociation happens. Okay, then usually we represent it. Okay, later I'll scroll back, don't worry. Okay, that dissociation actually happens and you get your H plus ions. That's why that's where it has its acidic properties lah. All right. Okay, so dry hydrogen chloride, okay, what happens is that it will ionize or dissociate in water to produce H plus ions. So the presence of the H plus ions give the solution its acidic properties. Okay, then what happens when you put it in methyl benzene? Then this dissociation will not happen, okay, because it does not dissociate, it remains as a molecule with H plus and OH minus absent. Solution is actually neutral. All right. Okay, so that's question 2D. Can? Okay, then you can pause the video lah. Okay, this is a recorded video. Don't need to be worried I'm fast. Okay, so the box below gives the names and formula of several common acids. So sort these acids according to their strength as well as basicity. All right. Okay, so strength is the degree of dissociation. Okay, is intrinsic lah. Okay, that means natural to the acid itself lah. Okay, strength is the degree of dissociation of acid lah. Okay, so you have the strong ones, okay, which are acid that dissociates fully, usually to give high concentration, and then you have the weak ones, okay, that only dissociates partially. Okay. Alright. Okay, so strong ones generally are the mineral acids. There's three main examples. Strong acid. Okay, you have the hydrochloric acid, sulfuric acid, as well as nitric acid. All right. Okay, the weak ones are all the other acids lah. All right. Okay, so then for basicity is a number of H plus ions that can be dissociated per molecule of acid. All right. Okay, so alright, so the strong mono basic ones are your HCl, HNO3, nitric acid lah. Alright, sulfuric acid is your dibasic strong. Okay, so sulfuric acid done, hydrochloric, nitric acid. Okay, the strong one is quite standard. Okay, the rest is actually all the weak ones. So we have strong mono basic, which is ethanoic acid. Okay, this is the only H plus that can be dissociated lah. The equation actually looks like that. Only this one can dissociate. The other three cannot. Okay, it looks this way. Okay, actually I should put stick symbol, sorry. Okay, then you also have HF. Then you have H2. This is your sulfurous acid. Alright, okay. So you have the sulfite ion down here. SO3 at the bottom, 2 minus charge. Okay. Then you have carbonic acid, okay, over here. Then you have phosphoric acid as well, okay. So this is a weak tribasic acid. Alright, so with that, okay, I have completed the first big concept for this chapter, which is on strength and basicity. Alright, okay, so my third video will be on the reactions of acids. Alright.